All right, welcome. We are doing 4coder Friday today, so it's not my usual binary cough object file, EPE file, generating, dumping, none of that. We are doing 4coder. Um, as a usual reminder, I am still, even when I'm doing 4coder Friday, I'm still only able to do this full time thanks to supporters and members, so that's at mrforth.com/membership. But let's move on. Let's talk about 4coder. So, since I stopped working on it a few years ago, the community has created a fork of the open source version that I posted, and this is what they've got. Now, these are build instructions. We're on Windows, so we're gonna see. Okay, we've got this. We can run CL. Call the package batch script from the code directory. So when I pull this, I'm gonna get code and non-source. Looks like they've put code and non-source together into one directory. cd 4cc code /bin package.bat. You can also use the build.bat script if you want to build the binary. You want just the binaries. This produces the build artifacts in the build directory. This doesn't produce a functional distribution. Interesting. Okay. Well, let's give it a shot. So we're going to try to we're going to try to clone this. GitHub. I'm used to Gitty now. Where is this? So we want to clone this. We are not doing Mr. Forth today. Well, this is still a Mr. Forth stream, but we're doing a different project. Git clone 4cc. Cool. Now the instructions say on Windows, I've got the toolchain set up. Yes. So call package.bat. So I cd into code. That gives me okay. And then I want to do ./bin/package.bat. Are we working? Ah, man, I haven't built 4coder in a couple of years. Look at that. It's kind of nostalgic. Build super. I actually hate it so much. I hate it so much. Hey, we got Terius Python and BYP here, both 4coder community vets. So, BYP has a 4coder quality of life layer, which I'll plug because BYP's done a lot for 4coder. So let's see, BYP's 4coder, is this the one right here? 4coder_BYP, is this what I'm supposed to show off? One Beneer asks, do you prefer a build system now? Kind of. I really don't prefer the 4coder build system. I have a hand-rolled build system written in bash scripts that I use. 4coder BYP. I'm not seeing a 4coder QOL. Oh, here we go. There we go. Yeah, why is that not? So here's, I guess it's not pinned. Here are all your repositories QOL. Okay, BYP, 4coder quality of life. I don't know. I'm going to check this out someday, maybe. Wow, you've put in serious work. Look at this. Wow. I'm going to have to really spend some time looking at what you've done. This is nice looking. Very, very detailed and organized. But let's see here. So yeah, I use a bash script build system, but I really don't like the 4coder build. It was just complicated. Like here, we're talking about this stuff already. Why don't we start with the build system? So let's go see. Let's go see. So what's going to happen? Just so we keep things straight, 4cc is a source repository I've just pulled. I still have the version of 4coder that is actually set up to run as my development environment. That's the one I'm going to be using. So I'm running 4coder as in the one that I always run, not the 4coder community fork. We're checking out the 4coder community fork today. And we're going to start with what we just did. Let's look at what the package script is doing. Package.bat calls bin build.bat with the package super location do we have like a mode bunch of options lined up right here. Build root call CL. I didn't even know if I needed. Okay, CL options kernel 32 lib for build. All right, so let's just start mapping things out here. I call package.bat, which calls build.bat with this, which calls CL for a build CPP with this and all this other stuff, and then it calls the build exe, right? Because this is building a build exe. So then it calls build exe, and that's the build system. So the build system is you use the build.bat, you can give it an option here, you can use forward build.cpp, and the options you put here tell build.cpp how to structure itself. Package super x64. So that runs the package function in the C code or the C++ code. And this right here, this is why I don't like it. I thought, like, you know, this is similar to like the Zig build philosophy, and I'm sure Zig build is better. I thought that building with my C++ code would be cool. Maybe it's just the API sucked. But this broke all the time, and it's like a lot of steps, and it is not even portable. You end up having to have, look at this. So let's just talk about this. In order to build C++ code, first, thankfully, I already know how to get CL working. If you don't know how to do that, you still have to solve that. That's a whole problem of its own, always an issue. But then there's, okay, well, what if I want to package on Linux? So we have a shell script for that. And so this one also has to do build script. So we have a build script that is parallel. So build.bat has to be written 3 times, right? Once for Windows, once for Linux, once for Mac. So keeping all the builds up to date. Build maintenance complexity is linear in platform number, right? So however many platforms I have, we have at least that much. There's a linear relationship between the number of platforms and the build maintenance complexity. So that's something I don't like. I would rather here's what 4coder has. Would be better if build maintenance complexity was O of 1, and that's possible. Yeah, the default key bindings aren't Emacs, and I don't know if there's a Emacs, just like here's the default Emacs stuff. But 4coder is designed with Emacs as the inspiration, so it's really just a matter of writing down the config you want, like whatever key navigation stuff you want, combined with whatever with whatever commands either match or closely approximate that. It's probably not that hard. But there's no default like preset Emacs style. So I've actually shown in an entire YouTube series how I would do this. Let me see here. I'm going to do this on the other screen for a minute. I don't know what'll come up when I type in YouTube here. Yeah. Mr. 4th Programming. Yeah, there we go. So if we look at my YouTube channel, go over here to my playlists. Build this right here. This series is exactly how I still build everything in the code base. And something like this would be much better for 4coder too, because this can build on Windows, Linux, and Mac with a single organized system. So if I was going to make a new editor, that's one thing I would do different right off the bat. The build system would be built like this. But let's keep going. So I can build 4coder. We proved that. Yep, the 4coder community /4cc is the repo I started with. So, I mean, I don't want to just start hacking away at making a new build system in 4coder without thinking it through. What were the build steps in 4coder? So 4coder had, right, we already have some of the story. You have to call build.bat to build.exe, fored build.cpp to compile fored into build.exe, run build.exe, which leads to the actual build steps, which are listed here. So we have also, what were the build configurations that 4coder wanted to support? 4coder had dev build x86, optimized build x86, dev build, opt build, dev build x86, opt build x86. Then it's your standard build. If I wrote down, right, then there was these options. So you could package the demo for x86 or for x64, and you could package the super version for x64. And this was basically the paid version. Back when there was a version you could pay for and a free version, the demo version was the free version with the custom layer closed, and this was the version where you got the custom layer. So these were for packaging up the full thing. Optimized builds are not for packaging up the full thing. They just turn on optimizations, whereas packaging turns on optimizations and it does things like rearranging the data files. And then these were for development. So it makes sense to have a package and a dev and an optimized version. It makes sense to have 32-bit and 64, but the fact that I had to do each of these as separate options was annoying. In my new system, okay. for building, in the way I build things now, this would break down a little bit differently. We would have, see, we have this right here. Let's go to Mr. Forth, bin, BLD core. We have things like, well, I think it'd be even better if we looked at like local, not init local. I'm looking for Mr. Forth, the local folder, local vars. So we would have compile mode, which can be either debug, or we can have compile mode be release, right? So that's debug and dev and optimized as an option. We also have architecture, which could be x64 or it could be x86. And so you notice this decouples. Now I don't need 1, 2, 1, 2, 1, 2, 1, 2. I would have 1, 2, 3, 4 options. And x86, 64 would be a separate switch, right? So that would be nice, right? And the compile mode can be debug or release, right? So the other thing you would have, finally, is you'd have basically, if you're building a package, what would happen is packaging wouldn't be one of the options. You'd have, like, build binaries.sh, and then you'd have build package.sh. And this would just contain the logic for these extra steps that needs to happen, and it would call build binaries. Build binaries would be able to run under any combination of these two options. So I'd have this or this, and this or this, right? And then when you run package, it could just force everything to be like release and x86, x64, release x86, and so on. There was also, at least once upon a time, if we go back to 4coder here, I thought there was, that's giving you the Super 60 x64 version. Maybe this is eliminated now, but there used to be a way to build all of them. We also need to be able to call zip from all of this. Okay, cool. So, Darius Python is informing me, and it sounds like we did used to package all of the different versions at once. Like, we'd get each architecture and demo and super, but demo has been eliminated as it's not relevant anymore. So the build scripts don't talk about demo, and x86 is not relevant anymore. So it's just packages just doing the one thing, right? Now, there's also a question of like, do I actually want those to be separate? I don't know. The hard thing is that like there is a nice thing about having the thing that's like, here's the shipping package be a little bit more complex than here's the thing that you do for iteration. Like this is for iteration while you're developing, and it's also, you know, can be used within the packaging thing, but packaging also does stuff like rearranging the directories so that your data folders are all nice and stuff, and putting it all through a zip ideally. I don't remember if that was a part of build.cpp. Did this call to the zip? Yeah, it looks like it did. And all of that would have gone into file moving, which was my attempt to make like a little helper library for building builds with C++. Nice. Right. Okay. So the thing I still haven't looked at is, say I'm doing build.cpp. What were the actual steps? Why don't we look at a standard build? So you had to do build super, and you had to do build main. Build super would include right, so it has to call. Here's another thing that gets nasty. So we have the 4coder code, it's all in one place, and then there's the custom layer, which is contained within the main repository, and it also has build scripts. And so it's now calling build super x64 dash the correct operating system as a script, right? So in this case, this one. And this one's also complicated. And this one does not go through the build.cpp because we want to make it easy for anyone who gets the 4coder custom layer to build it in one go. But unfortunately, there's no easy way to do that. It's one of those fundamental problems that I couldn't get past. Which is that if I'm shipping code to someone else and they're supposed to be able to modify it and start building it, if I want to make that so easy that they can do it on day one, then I want to make it so that it just uses whatever's default available. So batch scripts on Windows, shell scripts on Linux and Mac. And that leads to more duplication of the complexity, where we have, once again, the build complexity scales like the number of platforms. So again, I think these days, what feels like the right solution to me is, there's also stuff like this where I didn't used to have context cracking built into the code. I used to have to pass down which operating system we were on. Managing all the flags was always complicated. If I switched over to the shell scripts system everywhere, then it would mean if you were building on Windows that you have to have a git bash set up. And so there'd be an extra step. It's like, hey, welcome to building on Windows. Do you have your CL in your path? Do you have your bash scripts? Are you set up to run bash scripts? And then we would just get everything down to being one type of script. What else was in here? So build supers. There's also build metadata. Who calls build metadata? Interesting. So this is like the precursor. Build one time is my first step towards having a better build system where I can just pass in the targets. And by the way, are there two different project files going on here? Yeah, because there's a custom project file. Oh my god, okay. Yeah, so here's the thing. Batman, welcome. If you want to subscribe to me, then instead go over to mrforth.com/membership and become a supporter. I have a bunch of cool perks here on my website, stuff I can't give to you just by letting you subscribe to me on Twitch. And there's no point in you having to subscribe in 2 different places. So come over here, become a supporter, maybe become a member, maybe do monthly or yearly. This would be much better than being a subscriber to me on Twitch. Yeah, so the thing is, these days, if I were going to build this again, Terry's Python just said something key, and that's that the project structure is we have the 4coder like core project, and underneath that we have the 4coder custom layer. And these are 2 separate projects, but this project is sort of nested within this one. And this was important because 4coder custom contain things like base types. So this was before I had a single shared base layer concept, right? If we go back to my YouTube channel, where do we have that? Here. Do this again, youtube.com, Mr. 4th Programming. I'll just leave this YouTube channel up today. If we go back here, look at my playlists. One of my most popular playlists, the base layer. This, I learned that I needed this because 4coder was kind of a disaster. This ended up kind of becoming my base layer. And so it has things like my arenas, which are very different from the arenas I build now. It has things like, you know, built-in constants and date time. Very, you know, if I were to pull up Mr. 4th base and take a look, like we are basically comparing the base layer I wrote 5 or 6 years ago versus the base layer I've been maintaining in the last few weeks. And we can see things like context cracking at the top here matches up with context cracking here, except my context cracking now is super thorough compared to the way it used to be. Done. Right here we have all of that, plus language cracking and figuring out what intrinsics to grab, address size. I don't have names for the operating system and architecture. You know, that could be an interesting thing to add to my base layer. I now do snprintf with stb instead of from the standard library, so I wouldn't have to do this anymore. I don't have this, which would be necessary if I was going to do any 32-bit support. My basic types are different now. I used to do lowercase, but the thing is I really like to have my types be uppercase and my variables and functions be lowercase, with the exception of macros. I make them camel case. But since I do types uppercase, I decided to make my basic types uppercase and switch from I to S, because this stands for integer, but really what we're talking about is signed, you know, things like that. I just wanted to clarify, make them a little better. Still doing void func. Similar stuff. Glue. I believe I still do that. Yeah, so my macro style hasn't changed that much. The keywords, more macros. Asserts. Sizes. Swap. Ooh, here I have something I don't do anymore. There was a period in time where I was really into coroutines, and before I built the real coroutine system, I built this to make a sort of shallow coroutine. Clamps, I have to make those uppercase. Maxes and mins, all of this is kind of similar. Yeah. My macros for linked lists are very similar, except I've spelled them differently now. But you can see we're doing basically the same thing. Vector types. They have new names again. V2F32 is my V2 Vec2 over here. Man, I had a lot of these too, didn't I? I32, I16. Man, like I went all out just filling in all the different types. Wouldn't do that anymore. Ranges are still in the thing. Okay. Wouldn't type Jeff a U32 for colors anymore. Date time, still a thing. Strings here. Way more complicated. Way more complicated. So I got all these things labeled string const. And oh my gosh, like look at all this. Look at this crap. So we got char type, U8 type, U16 type, and U32 type. I still do a string 8, string 16, and a string 32. Right, we got string 8s. We got string 16s and 32s. That's nice. I don't bother with string char anymore. You can see I even started using that shorthand by the end of 4coder. I don't deal with string arrays anymore as like specific types like this. Do I actually use an any anywhere? I've got one string any. So lame. No, none of that needs to happen. You know what, Darius Python, that's a good point. That is weird. Make a note to fix my base layer up even more. Straight lit. Hey, that already existed in 4coder by the end. That's cool. Here's the string lists, but now I have to make 4 string list types these days. So comparison, point of comparison. I only do string lists for the string 8. Basically, I do all of my work in string 8, and string 16 and string 32 only exist as conversion endpoints for convenience. So, like, if I have a string 32, great, I'll pop it in here, make it a string 8, and then I'll do all my work in string 8 for a while. And if I need it back in 32 or 16, I convert it. But I don't do lists of string 16s or lists of string 32s anymore. Here you can see me converging on the new style that I use by the end. And here we have the really nasty cap and size type strings. We have like a constant string and separately a cap, which is like capacity, lets us modify our strings in place. I just don't do that anymore. I have the consume result. Let's see. Encode. Yeah, string decode. Code point size, code point inc. These are the same things. Access flags. Interesting. I've never made that base layer level before. Do I have... Actually, I have now. Since I... Interesting. OS mem... Yeah, but I never did it here. Okay. We could use the access flags that we already have to make an API for that if we wanted. we've got all that. Date, time, we've already looked at that. 4coder base types, blah, 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 blah. Okay. So back in the day, I used to do this really complicated thing. Like we'd have, sorry. Yeah, we can see here we had reserve, commit, uncommit, free, and then set access. And I'd create one of these, and I'd have like this virtual table. Now I'm just like, there's only one. It's statically known. I'm missing the set access, but we can fix that sometime soon. The cursor, base types, default hooks, cursor. Okay, here's an actual mention of the real cursor type. And what are we doing here? List all functions. Get function positions. So you can see here I had it to rewrite get function positions to allocate on an arena. So there was a period of time where I didn't have proper arena pass through everywhere. And so it was not the case that functions that allocated actually were guaranteed to be compatible with arenas everywhere. How did this allocate then? I don't know. Token array from buffer, token iterator. Okay. What I'm trying to track down here is seems like this cursor type. Okay, got used here too. This cursor type is like the low-level arena, the linear allocator with no reserve commit, no chaining. And I used it in a couple of places for some reason, and I'm trying to figure out why I would do that. It could just be that I was lazy and didn't finish. Begin buffer insertions at buffered. Decals buffer. What is this function doing? Buffer insertion creates a cursor. Begin temp buffering. Buffer insertions. I think this was an optimization. So I think what was happening was writing to the buffers a bunch of small strings was sucking, and so this was like an extra layer of buffering. Brioman asks, is 4coder still in development? Well, 4coder has been in development by the community for a little while now. So ever since I open sourced it and stepped away from the project, 4coder community fork took over, and I am checking it out today. A lot of 4coder community fork is the version I made, but it can't take away from the fact that the community has in fact done stuff. I mean, look, this is all not me. So there's me 2 years ago, and I'm done. That's like the end of my involvement. And then since then, the community has made some progress here and there. And it would be interesting, one of the things I'm thinking about doing would be to go look through some of these changes directly and see also what they've done. But a lot of what I'm reviewing is still my code. So when I criticize stuff, it's mostly me criticizing myself, not the community team. Yeah. So I think that this was just like a sloppily made buffering system for inserting into a buffer more efficiently. And that's all the cursor, that's the only point this cursor is serving as far as I can tell. Like we have 4coder insertion. We have the definition of cursor. We have 4coder insertion. Function list uses a cursor because it's using buffer insertion. Here we have the definition of the cursor type. Cursor, cursor, define cursor, X cursor, undef cursor, switch to new cursor. And the rest of this is about the actual 4coder cursor, like the interface cursor. So yeah, this is just like a really unfortunate piece of crap that sits in the base layer of 4coder because there's one little spot where it depends on that. And if we look at where's buffer insertion depended on, well, here it's getting defined. Here it's getting used. Looks like it's getting used here, but I did not pass it a cursor. Why would that be? I don't exactly know. Interestingly, this is one of those spots where I'm annoyed with 4coder. I don't want it to create headers this way anymore. This is the default header construction, and I would change this right now. But I'm not going to start changing things just yet. Render documentation page. Okay, so I also used buffer insertion there. And here. So it looks like anywhere where I did not pass in a cursor, right, overloaded functions. I can instead pass in an arena and a size, and then what it does is it creates the cursor on the arena and puts the cursor there. Either way, it's a fixed buffer size. Okay. Got it. I wouldn't do that. I wouldn't do this. What are cursor nodes for? Is this how I implemented chained arenas? Oh, that's so cute. That's so different from how I do it now. So an arena is a chain of cursor nodes and a base allocator. Wow. Wow. Okay. They're a doubly linked list for some reason. Fair enough. Okay. Now, why would I need a generic temp memory that could apply to either one? Nobody knows, right? Oh gosh, it's a deconstructor. Temp memory block. Is that why? Scratch block, temp memory. Oof. Okay, so 4coder is using C++ deconstructor / destructor methods. Here we can see the beginning of the conflict arena concept. You see this? Whenever I was getting a scratch, I would use a scratch block constructor, and I bet you that right. Reserve. It's just overloaded functions. Man, I wouldn't do any of this. This is so much code just to like make it kind of sort of like clever feeling or something. I don't know. It's so many functions. Do you see this? Like all you have to do is like this. Right, so we have an arena get scratch function. It doesn't quite look like a normal function because I've worked up the syntax with these shared function macros. But basically, this is this function: arena temp, arena get scratch with this signature. Right, so I'm passing a conflict array. Now, the reason this works is that 99% of the time, you're either putting 0 or 1 conflicts here. In fact, I'm at a point where I don't usually ever have anything but 0 or 1. But if you wanted to have more conflict, then all you have to do is go, okay, well, here are my conflicts. I'll start with an array, and I'll go arena 1, arena 2. And then when you call this, you just give it your conflicts, right? You're just like, here we go, array count conflicts, right? So you can pass any number you want. You can pass 100, right? There's no need for an overloaded function. And then you'll see here, I'm hand coding. What do you do with 0? You do this logic. What do you do with 1? Well, it's the same logic, but you got to do a loop and compare that it's not A1. And then you got to do a loop and compare that it's not A1 or A2, and so on and so on. If you just do an array as your variadic input instead of overloaded function, then yeah, you end up with one bigger function. Although a lot of this is bigger for like reasons that don't matter. This is initialization on the first time, which I didn't used to bundle in. But then here, we just have to loop over all of the slots in the scratch, and then loop over all the conflicts in the array. So however many you pass, we do a loop here. It's not hard-coded how you do it, but there's just one function. We don't generate 4 different pieces of code to accomplish this. We generate one piece of code that accomplishes it for all cases. That's the way to do it. And also, don't bother with the C++. Doesn't make a big difference. Yeah. Also, you don't need an explicit thread context struct. Just use thread local variables. And then I have a little heap implementation. That's fine. That doesn't bother me. I don't have one of those in my current system, but I understand why I probably needed it in 4coder, and I'd maybe end up in a similar spot if I worked to it from the same direction. So going back to Scratch here, what 4coder has is it has this base layer that lives in custom that actually needs to be shared between them. And then what I would really prefer is if there was a single series, like a single flat system of separate projects. We'd have our 4coder base, which would have our base layer in it, things like operating system abstractions and so on. We'd have a core, which would have things like, you know, this stuff, initialization from command line, the main step for the whole like function thing. God, 4coder code is so goofy looking to me. It looks so different. It looks so different from my code now. I can just feel all these funny things like the notes everywhere instead of it just saying this, and temporary memory blocks on the scratch, and it's just a lot. It's a lot of stuff. Which is what like 5 years of iterating on text editor looks like, I guess, though. It's a lot of stuff in here. It takes a lot. A lot of features. But then what would happen is these would kind of each be subordinate to that, or they wouldn't be nested. This would have base layer stuff, and these would have include 4coder base as sort of like a pointer into the stuff that it needs. But then the custom layer and the 4coder core would be built separate. They'd have their own builds like this. I think something like that would be more appropriate, because then when you ship 4coder custom, what you'd be shipping is you'd ship the base and the custom side by side, and you'd have the build in here for building custom. And when you ship the core, you'd ship the base and the core. You could ship the custom side by side with it, but you'd just be including or excluding this rather than extracting it out of this context here and then having the weird bridging between them. The base layer would be shared. And that, by the way, is why when I've been working on Mr. Fourth Base recently, I've been really taking into consideration that I want my base layer to be able to function more like a library, and a part of that is making sure it can function across module boundaries. So if I have an exe and a DLL, if I have a 4coder program structure with a core program and a custom layer, I want a base layer that the two of them can share across that boundary. And I used to achieve that by basically putting the whole base layer in the custom layer and having the exe load the custom layer and depend on it, but that tied things up in so many nasty ways, right? Let me actually switch to drawing you a picture for this part. Let's take a bite of our cookie. We need Milton. Okay. Here's what happens. You have the 4coder custom layer, and it contains inside of itself the base layer, plus other stuff. Then you have your core. It's a separate module, and one of the things that core does is when it initializes, it looks for and loads a custom layer, and then it goes in and grabs that base layer that it needs just to do its base stuff. So it gets its base layer. Through this dependency here. Does that make sense? And what that means then is there's not really going to be there's just no opportunity for something like easy hot reloading of the custom layer, because the custom layer is integral to the whole with this architecture. We kind of load it up once and we count on it to stay there forever. We'd have to be more careful and say like that hot reloading of the custom layer was a goal to even get there. It also means there's no opportunity for dynamic plugin architecture. So something with 4coder is if you have plugins, the plugins are basically libraries that you build into a custom layer. There's no such thing as dynamic plugins where you just take a DLL and load it in. There could be. You could build a custom layer that defines a real plugin system. But the core does not do that. Okay. Okay. So we got through base types. That is one of those things that ties up the project structure a lot. And then because of that, the builds here depend on the builds here, and the builds here contain a lot of stuff. Like, getting back to this. Right, so this is going to pre-process the file once. Then it builds 4coder metadata generator, and it runs the metadata generator. So we were listing out what this does. The built superscript has to do things like pre-process the target and compile the 4coder metadata generator, because I was really into metaprogramming as a solution to everything. And then we have to run the metadata generator on the pre-processed file. And then we actually have to build the target for real, right? So that's all the steps for build super. Actually, the architecture is worse than even this, because there was another layer here that would go like this. And this was inspired by the Handmade Hero division. So there's like the EXE is a platform layer, and the core thing that's the same every time is a DLL. And then separately, which was not from 4coder, the custom thing was also a DLL. And this is not actually necessary. Like, I understand it made some sense in the case of it made some sense in the case of Handmade Hero, but like, I don't really like the way this felt for 4coder, having another EXE just for the an EXE for each platform, and then separately building the core and the custom layers as if the operating system didn't factor in on those built modules. But it still did, and it didn't really help to have it separated out as separate modules at that layer. So this builds for an app. This builds platform OS / OS fored.code. Oh, man. So let's think about this. Why was the build super doing all of this? The main reason... where's a good... The custom layer is not set up in a way where it's obvious where you actually want to look. 4coder... base commands. Does that give me something good? Yeah. So here we can start seeing that what was happening with 4coder was I had these function signatures that came in through the DLL, and they wanted to act as commands, but they wanted some metadata attached. So each one was a function pointer for implementing the command, plus some data. And so all of this, the pre-process, the metadata generator, and the metadata generator, was about turning this into this, right? Now some of this didn't need to be generated code, but I was generating it anyways because I was weird. And it includes things like the documentation string, the location information, and that would be hard to do without using the pre-process trick. The pre-process trick really did play an important role in making that possible. So I'm seeing a lot of things here, and I'd love to sit and talk about a little bit of this. One thing is the language itself doesn't provide the tools for making this easy. And that's a part of it. And you know, if we picked up a language for programming that had good metaprogramming in it, then this would probably be less painful because we wouldn't need to pre-process the file and write our own parser and then generate the code that we actually build. All of this would just be part of the language, and so it would just be a build, in theory. But I think it's not just that, because this is sort of a thing you would want in general if you knew you were going to support things like customizations, if you were going to support things like custom layers. You wouldn't want to have to metaprogram to get these features either. Like this is to me an example of the toolchain problem. The languages that we're building still have to output object files and executables and DLLs with the same data structures that C outputs. So even if you have all the metaprogramming in the world to kind of help with this, what you really wanted was you wanted things like the names of these functions to be a part of the binary data structure. You wanted the idea that associating location information and documentation information all together, and whatever other information you would care to associate with a function, would be not just built into the language, but built into the native architecture. because what's happening here is I'm creating a DLL with all of these functions in it, and I know that that DLL is working like a plugin or like a custom layer. And in order to report from that DLL to the exe all of these features, the main thing is we're trying to say, like, here are all the features that are available. Here is code that you should plug into your main program. Get the main program to be more powerful by having access to all this new stuff. And here's metadata about it that makes it searchable and comprehensible, and that allows you to develop the features further and so on. And we are having to package up that data in data sections and report it through. I feel like what I would want is the ability to say, like, some symbols are going to have data attached to them, and specify what types of data I'm going to attach to different types of symbols. So like here, the default stuff, name, fine, location, information, fine, but the description is a little bit custom, and is UI is definitely custom. I'm sure some of these say true. Yeah. Huh. Gives me a lot of ideas. It's a lot to process. So if I'm going to keep programming in C, one piece of this is, even if I were to invent new data structures that I would like to output, I can't, as long as I'm using C compilers that I don't have control over. I'm still going to be outputting regular old object files and binary files exactly the way they are structured now. What I could do is run the compiler and then modify my binary files in place. I'm not sure that would be any cleaner than having to pre-process my code and then metadata, generate metadata and then compile. Right now I'm not trying to fix anything. I'm just reviewing how code in 4coder worked. So I'm wondering if there are any of these that said anything other than custom doc afterwards. I can't remember if there was ever a single time that was allowed. Like if there was an alternative or an extra thing, if there was more you could put down right there. We're gonna find out. So here are 4 declarations. Gross. Handwriting code through a generator. Never need to do that. The examples are bad. Valbus, I don't really know what 4coder Casey's using anymore. I don't know if he's still on 4coder. Last I knew, he mentioned that at least internally at Molly Rocket, he had used 4coder as a starting point, but done a deep rewrite to make his own thing out of it. But I've never seen that myself. I just remember him mentioning it a few times. And he hasn't done Handmade Hero in a while. I think Handmade Hero might be done. I can't remember what he said about Handmade Hero, but I believe he's still using what he did. The version of 4coder that he made with me, I believe, is still the one he uses on Handmade Hero if that ever happens. Okay, so there is this UI command sig version. BYP play music was a thing because Casey wanted the ability to play audio from 4coder to make like alerts and stuff like that for like when things completed or something. I don't exactly know what he wanted, but he built those initial versions of the features and threw play music in there as a test case or sort of like proof of audio system working feature. Yeah, it's the same thing as a command. I don't know why the signature wrapper was different, except that I wanted to mark which ones were UI commands in the metadata. So here's the push and pull. If I just have you define your functions like this, right? We have like foo bar, and if these are your commands, and then so you're writing your my 4coder plugin .c, right? So we're just brainstorming here. We're thinking about how a good plugin system might work. Here's my 4coder plugin .c. And then somewhere in here, you have to have, like, so here's like the C version day one. Whatever. Right? So you'd sort of imagine like day one, you're just outputting these. Maybe you're going like command type info or kind info here. Right. I remember there had to be a rather complex UI related sort of stacking reason for keeping track of whether or not a command was a UI type or not. But the point is, in a day zero version, you would just write the code, and then you would declare the metadata in one place. And if you fail to declare your metadata, it just wouldn't show up. You'd load your plugin, and foo would be missing if you forgot to put it here. So what's nice about this is that it's something you can just write. There's no magic, right? You can just write this. We write regular functions. We write regular code. We don't have to do any metadata. We don't have to do any macro tricks. It just works. And as soon as you decide, hey, it would be way more convenient if I could do something like command regular, insert what's coming up, right, and put that before the function declaration right here. Now all of a sudden it's like, okay, well, are we going to parse? We're going to have to parse the file, so we're going to need to write a parser. Whenever we find one of these command things, the thing that comes after that has to be the function signature. So we got to parse out the function signature too and put that together. And then once we're done parsing, we have to generate. And what do we generate? Well, we could generate, this wouldn't exist, but we could generate an X list. We could be like generated command X list X, right? And then go, okay, we've got write text input, command regular, and here's the string, right? So we could generate this thing. And doing this is nice because at the very least now, unlike here, now you can automatically do other stuff like, oh, also throw in that we're talking about the file my 4coder plugin.cpp. Full path my 4coder plugin.c, line number 3, right? Like we can just drop all that into our X list like that. Because it's generated, so when we're parsing it, we will get that data here. Whereas we would never really be comfortable tracking that manually because it'd get wrong so often it wouldn't be worth it. If we needed to forward declare anything, we always could by doing this. Right, so command decal would just give you that. And when you make a command, you would just go like write text input. Right at the end, we'd put the function name. Or we could put it right at the beginning. Right, command, regular, write text input. We could do command, write text input. We could also then have the name of the function pop in. I mean, our X list would already allow us to get the name of the function out anytime we want. So then, if that's still ideal, that still implies a metadata system. We still have to write a parser and run it. Now the question is, could it be simpler? Metadata generator. So we are listing out all of our files. Grabbing the name. Jesus, that's annoying to me. Whoa. Wow, I was up to some crazy nonsense. Do you see this? This is why I had a string const any. Because I was thinking sometimes I use Windows and I have 16-bit strings, and sometimes I use Linux and I have 8-bit strings. So then this was not always the same type. So this was not always coming the same with the same dynamic type, because this was an overloaded function. And I don't like any of that. That's so confusing. Like, a type should just be a type. It should be the same size on every platform. If you have cross-platform needs, the way to do it is to convert out, like at the boundary. This right here is letting the type differences leak through so much of the boundary. And it sounds cool to do that, but it ends up with all this weird, confusing nonsense, where eventually I end up needing to make a string U8 anyway, so I do end up converting. So why didn't I just convert from the beginning and simplify the types? You know what I mean? one way or another, you end up needing homogeneous code paths. It's the only way to make things maintainable in the long run. So, anyways, I grab the file. Eventually, I assume I'm gonna actually have a file name and be able to read it. Yeah, so here I finally have read the file. I'm done fooling around with the name of the file, and I've got the file name. I read it, and then I parse it. And we are looking for one of those. It still feels to me like running the preprocessor was the best option. Because what running the preprocessor does is if you're gonna write a parser, if you're gonna have to write a parser, then at least you don't want to have to do things like spanning all the files yourself, right? If your compiler can be used, if the preprocessor in your compiler can be used to gather up all the code into one stream, and then you just preprocess, or then you just run the metadata generator on that. That does simplify a lot. So let's see here. Yeah. So it says I'm doing recursion, but really I'm just running metadata generation on a single file here, which is a lot simpler than what the code was expecting. The code was prepared for like recursively exploring the folder that it's pointed at and pulling in code from all the files that match a pattern. And so all of that was extra. I believe this could be much, much, much simpler, and it might not even need to be in C or C++. Like this could probably be a bash script metaprogram so that it doesn't have to get built. It could just get run. We would run the preprocess. We would run the bash script to generate the X list, and then we would be done. I think that could be done. All right. What else did I do in 4coder build system? So that was that. The build target. We already talked about the fact that I think these don't need to be separate. There's this. So I think something like this. Right. Something like this could be the deal. So while we're at it, while we're talking about all this, I just point out something else, which is that I have so many warnings that I am manually disabling here. If we were to go look at what I do in Mr. Fourth codebase stuff now, BLD, compiler flags. You can see I do turn off a couple of clang warnings here. There's no CL warnings that I've turned off. But I also haven't turned on W4 or WX, it looks like. So 4coder was building under the constraint that I had to have no warnings in order to complete successfully, which I still do. You know, if I were to go build any of my Mr. Fourth stuff, I don't leave warnings, but I also didn't have warnings turned up all the way. And so that's probably why I ended up turning off a bunch of these high-level warnings that were annoying to me. But all of that would end up here in the flags. This, and this are already here in the flags, as well as turning off exception handling. Includes are handled better. This is handled by the context cracking. This is handled by the mode system. Yeah, just like everything would be better. Mixer ID, yep, I'm reviewing 4coder code. I'm comparing how all of it works to what I would do now. My ability to build DLLs is already better in the new build system. I wouldn't need to manually mark the exports in the build because I know now how to do DLL export markup that actually works. So I would just mark things as sim runtime symbols to export them. Yeah. Okay. So that's my comments on the build system. I think that pretty much sums it up. What I would do differently is, first of all, I would switch over to my new bash script system. That way I wouldn't have this situation where each build script has to be written multiple times. Right now I have a build script for each platform. What is build.bat? This must be the Windows build. I have a build script for each platform and architecture combination, which then all point to build.cpp, which drives all the different individual build targets that need to be hit. For build super, it then goes to the build super scripts, which are, check it out, also replicated for each platform and architecture. And what are things like this? Setup x64. Looks like I was fighting against trying to get the different architectures to work, which I have much better control over. So yeah, BLD, I'm just going to say this again. If you look at my BLD system here, this solves all of the problems that I was having way more cleanly than what I did in 4coder. Sampy159, what's up with checking if it's CL or clang when both defines are the same? Well, for one thing, I might end up with more, and I kind of like keeping my lists of things parallel. So like here, it matters, and so just having the structure be the same over and over again. The fact that it's code is true, but like it's a homogeneous structures make life easier. So you'll see like right here, I didn't do that. I could actually be going if, elif, right? And put this on top. There is another piece of this which is a little bit annoying that I am sweeping under the rug when I say that I want homogeneous structures, which is that sometimes Clang looks like CL, and so being careful about which one, like not getting confused and putting Clang stuff or CL stuff first to get the defaults right in case both of them appear true is important. Although I think my context cracker now doesn't suffer from that. I believe I have solved that right at the beginning. So like if it says Clang, we know we're Clang. Even if it says MSC version, it's only a compiler CL if it says MSC version and not Clang. So I think that's all sorted out now, but I can't remember exactly. But short version is I don't overthink simplifying the structure when having things in parallel is nice. Anyways, so so all of this would get cleaned up by my bash BLD system. The problem of pre-processing would still be an interesting one that would have to happen. So we would need to extend the BLD system to have a command for pre-processing a file. And then I would probably write my metadata generator as a bash script instead of as a C++ file, because that would simplify it quite a bit, and it would make it one command line here instead of two. And then finally the build here. So all of this would be turned into all of this would be turned into call build binaries.sh, which would be directly responsible for, let's see, if I had a custom layer, there's still this question of like, does the core know about the custom layer? It might be that we need I would want to take some time to make it so that if you were building custom layers alone, it would be easy to do so. But maybe I would just assume if it's going to be an open source project, for one thing, there's no point in making it so that you can hide this. We could just say that you always have all three, and that this builds custom, this builds core, and so there would be build core would just do like BLD unit for a 4coder main or something like that. Call build custom would do BLD pre-process target and custom metadata on target preproc. This would come out as target.generated.h. And then finally BLD unit target, something like that, maybe. Mixer ID. Context cracking is when you have code that you've written that could run under different contexts, and you want to use the code itself to figure out information about the context. So In this case, for instance, I'm figuring out, am I being built by Clang? Then I'm this, then this is the Clang compiler. If I'm on Windows, then I'm on the Windows operating system. Linux operating system, right? And then we go, oh, well, what if we're being built by the CL compiler from Microsoft? Well, then I'm a CL compiler and I'm on Windows under this condition, or we don't know what other operating systems we can hit. Figure out what architecture we're on. Am I being built by GCC? Then which operating system am I on? And so on and so on. So we could say whenever we build these things, the build line will have all that information, and then the code doesn't have to figure it out. But that's a lot more extra work. If I can just say, here's the code, and the code figures out for itself the current context, that's very convenient. And that process of figuring out the information you need about the current context from within the code is context cracking. This would contain something like that. Although we could just say bin could live outside of all of these, right? We could just say there's going to be a bin layer right here. It's going to contain the BLD system, and it's going to contain the build scripts for core and for custom. So the full project is like, here's a bin, here's the source for the base stuff, source for the core stuff, source for the custom stuff, and here are the scripts for that. And then if you go and build a different custom layer, you just target the custom build script from here at different custom layers. I think I would prefer this, or at least I'd love to have tried it this way. Let's see. I think that's everything about the build system that I'd like to review. I mean, again, obviously I wouldn't have built everything with build.cpp if I was doing it now. I think this made things way more complicated than it needed to be. There were also some packaging steps that I've skipped over. So like if you do want to have a package version, call build package sh would be responsible for like, this is call build core sh, call build custom.sh, and arrange data files. So it'd be like call what does it do here? It's grabbing a copy of each of those. It's doing the zipping. Where is it doing? I guess build main was actually responsible for, yeah, moving data files. Something like this. This is so lame. I can't even tell you. Okay. And then our bash parser just has to scan a file for command, right, like this, right? It's got to find command and pull out from the parentheses each of these things and save a file name and line number. And then once it's gotten all of those and made a big list of all of that data, it generates one giant X list. You know, it could also just do this, right? It could do a file style X list. Yeah. So I'm going to take all of this and save it as notes. September 6th, 2024. Here are the notes I have so far. I'm not committing to doing any of that. I'm just thinking about what I would have done better, and I'll perk on the idea of if it's possible to actually make any of those transitions without hating it. But there's a lot more to review. So I'm going to wrap up for today by looking at what else we might want to look at in 4coder. So we looked at the build system today. What else is going on in 4coder? Well, we looked at the base types as well. So we might want to take notes on how to improve the base layer. Yeah, this is all super complicated. Some of this is overly silly. And there's a lot of features in 4coder. It is easy to forget. Like, here are all the end of line related features. It's a lot. I mean, it's only a few hundred, it's only like 100 lines of code in this file, but there are so many of these. Async tasks. How many async tasks actually got used? Well, my headers. They're not very organized. God, there's the whole Lexer generator. What else? The project system. There's the frickin' Win32 clipboard bug. MixRD is asking a good question. Are you going to do something new with 4coder, or is it just for you? I'm right now not sure what I'll do. I'm not committing to getting started on 4coder again. I'm not committing to doing any changes to 4coder. I'm also not sure if maybe what I want to do is start a new editor or a new project inspired by some of this. But for now, I'm just doing a giant, like, long form retrospective. I'm doing deep code critique on 4coder, pointing out all the things where I gave a short, when I finished with 4coder, I gave a very, very brief, like, here are the things about 4coder that I currently don't like. And that's in the final version of the repository I published. I am doing that now in much more detail and really looking at all the stuff, because it's been a few years since I touched it, and now I'm not even attached to the code in any way. I can kind of just point out all the stuff that I'm like, this isn't the way I do things, and there's a lot of problems with it. So yeah, I just thought it would be useful to read through all this and see what I can point out as, like, this might look cool, but these are actually mistakes, and here are simpler ways of doing it. So that's what we're doing. That might involve actually rewriting some stuff at some point, and if I do that just for the learning of, like, hey, here's an example of how this could be better, and it works, then I'll contribute it back. But getting code working is a little harder than just pointing out roughly the sketch of how I would get it working if I was going to. So I don't know. I don't want to commit to stuff like rewriting 4coder if it's gonna absolutely the config system, the config grammar. Oh, yeah. That stuff is off. Yuck. Yuck. Valbus, getting rid of OpenGL is not that big of a deal to me. But I did always, you know what, that is a good point. I did always want to be able to have an abstracted renderer so that I always wished I could have done an abstracted renderer so that it would be easier to plug in different graphics systems. Implicit conversion casts in C++. I don't know what you're referring to there. Are there places where I'm relying on? Oh yeah. I know what you're talking about. Cast operators, operator overloading in general. Sooner or later, we have to talk about virtual whitespace and auto indentation. That comes up here with language handling. And probably we want to throw the code index in there as well. I haven't looked at the 4cc GitHub pull requests, and I haven't looked at the 4cc changes that they've made either. Oof. What is this? This looks like something that got generated. Documentation system. Complex stuff. Some of that's like real stuff. We actually need lots of that in 4coder, and it's easy to forget how important all that is. We should definitely talk about the coroutine system at some point. That's actually not a bad part of 4coder, but it's interesting. Just take a look at how we ended up handling fonts. Okay, I think that's a lot of stuff. I think that is a lot of good stuff to look at in the future. This is going to be a long project with that many to-dos, but we've got a lot to get through. Oh, look at this. Win32 UTF-8. Did I still... Ugh, this is not pretty. A note from Casey. Man, there's a lot of Mac stuff I don't know about. A lot of the Mac layer was not written by me. So that would be a whole extra difficult thing to get into sometime. Just figuring out how we would deal with Mac again. There's also a bunch of Linux stuff that I don't know about. Oh man, metal. Okay, I think that's good. Helium XXX. Yeah, so far I have not committed to doing a new 4coder or a new editor of any kind. I'm just doing a deep code critique to see what kind of stuff we learn along the way. I thought it would be helpful, and I think it was. Like, I do feel that it was nice to come back to this and just see the gap. Also help other people who've been 4coder fans see the distance between what I do nowadays versus what I did in 4coder. But who knows? If I keep at it for a long enough time, I might end up finding myself making a new 4coder with a bunch of stuff cleaned up. It's possible, but it's not really a high priority. I'm doing this one day a week, 4coder Fridays. But we're at the end of 4coder Friday, the first 4coder Friday of the new series. So I'll remind you, if you like this project, or if you like my binary file deep dive project, or any of the other stuff that I mentioned here, any of the things I'm doing on YouTube, then consider supporting me by going over to mrforth.com/membership. There's a couple different options. You can go monthly, you can go yearly, you can do it one time or let it keep going. And you get cool perks. You get, I'm about to go send out the weekly devlog. You get, if you become a member, you get the indexed video library. So all the things like my build system that we were talking about a lot today, you can go check out the indexed version of that and search around and see what I do. Yeah, so check that out. It's much appreciated. If you aren't ready to put money in, you can also go to the homepage and get on the newsletter, and you'll get at least basic updates that way too. And with that, I will see you all around the internet. Bye.